welcome to Turn Right Machine Works. My name is Keith, and today we're going to start on a new project, and this is a hydraulic motor that we are going to create a coupling from this spline shaft on here to a straight shaft coming out of the winch assembly that we're mounting this to. I've already taken a 1-inch plate and plasma cut and machined this whole pattern, and they've made the base plate, and they've got that wallet in place now, and the barge is being painted up, or the winch assembly is being painted up to mount on the barge. And now I've got to create a coupling that will join this spline to the straight shaft, and we're getting ready to set up on that piece in the lathe there. But I wanted to kind of show you a few things here while we're going to be roughing out the main piece of material for the hub that we're going to create. I've got another piece or use here of my favorite caulking here, which I call monkey shit, and we're just kneading it a little bit. You want to get it softened up, and this spline here is actually an involute spline. Instead of having straight sides on the spline itself, they're angled, and so they call that an involute spline. And this happens to be this is a European model, and this is not standard to our American standard splines like it's in the machinist handbook and stuff like that. So what I'm going to do is I'm basically just going to be creating this spline coupling just like I would be looking at any other form tool machining. Alright, now I've already taken down dimensions and all of that, and basically we've got 14 teeth on here, and we're right between 2 7/16 and 2.5 inch on the OD of the spline itself. And we'll be coming in here with, I'm going to go ahead and use my gear tooth calipers to go ahead and create measurements off of the individual tooth. But for right now, I like to take and cramming this right down into the spline itself, and I kind of, if you even off the front edge here, and this is just give you a rough shape. And when you start hand grinding a tool, which we're going to be working on a little bit later, but I just want to kind of cover that while we're sitting here talking about the job and what's going to be going on. And so first off, we're going to be roughing out a hub so that we have a length, an outside diameter that's going to be nice and clean, and we're going to put a finished bore in for the straight bore side of the coupling, a relief in there, and then a minor diameter of the spline on the other side of the bore. And then we'll be taking it and we'll set it up in the K&T with our jumping jack or broaching head, and then we're going to go ahead and we're going to slot or broach, single point broach these splines right in there. And we can take this impression right here and actually gauge it to get a rough gauge on our part while we're doing the grinding. And you know, we can always squish this in and keep remaking this shape and using this as a rough guide for our tool. And then when we get down to the nitty gritty, we'll be able to take our gear tooth caliper and go ahead and create an example, or use it to gauge that tooth. Now we're going to be given a little bit of clearance because they've taken this plate and dialed it in and set it in there, and this is a pretty big piece of equipment here, and there's going to be a little idiosyncrasies out after they've welded this thing and motion and stuff like that. So it's not going to be a super butt tight fit on here, but we're hoping to have just a good slip-on fit right here. Now we're also making the coupling, because this is a hardened shaft here. I'm going to make the coupling out of 8620, and I'm going to leave it in the annealed state. It should be tough enough to handle the load and not be brittle enough to where the difference of the two metals are not going to create a shattering problem if torque exceeds the limit there. Alright, so right now let's go ahead and get into the lathe here, and we're going to start roughing off the piece that I've already got cut to length. rough length right now, and I just wanted to talk a little bit about the spline, kind of how we're going to be going, where we're going to be going with this project, and give you an idea of the part that we're actually trying to mount up. Alright, let's head on over to the lathe. Okay, we've got, this is basically a hot roll finish surface, and then this is just a hacksaw or bandsaw cut here. So what we're going to do is we're going to go ahead and we're going to just smooth this, and go ahead and smooth this outside right here, so that we'll have a surface that we can go against the chuck and hang on to the jaws here, and have a relatively good smooth surface. And we'll turn this so that we'll be able to indicate right here just to make sure that we are running true there, and we know that this against the chuck face will be running true. Then we're going to go ahead and we're going to do the entire bore and other surface in one setup, so that we'll be able to hold it and do our broaching and everything else true and concentric, with it being held in the dividing head. Alright. Taking about 20 aside here. That's all I'm looking for, is a nice clean surface on the outside. And we'll take it down and suppose we can get to the chuck without touching it. Alright, that's good enough finish for me, and this is flat enough. We'll go ahead and break that corner there. Alright, I'm going to go ahead and while I've got it here, I'm going to go ahead and drill in, and might as well take some of the material out of this side here instead of pushing the drill all the way through that whole 6 inches from the other side there. And I see a little light hollow right there that's starting to skip there. I may actually take just one more skim on here just to bring that down, so that we do have a nice clean coupling on the outside there. Because I don't plan on actually doing anything to this outside surface after we rotate this, except for bring this cut in to blend it. Alright, we're just going to go ahead and we're going to go in with a 1/2 inch drill bit here, and we'll go ahead and we'll take it in about 3 inches. Alright, now we're going to step it up to a larger drill. This is a 1 3/8 here. Bump it a little bit, but I'm happy with it. I'm going to go ahead and take a 15,000 cut off the OD here. Alright, and there's a little hollow that we were telling you about there, and I did take another little light cut on it before we actually turn it around. Okay, I'm going to need 3 to 4 micrometer here. Alright, we need to get down to, we did go down to about 37 and a half or so, 937 and a half. So it's going to be like 3 15/16 on the OD here. Alright, we just got through blending this in, and we finished poking through with the drill bit on this side here. So we need to get rid of some of the swarp, and we're going to go ahead and we're going to wind it up on our Wonder Wand here. Make a couple trips to the trash can. And kind of clear it off. You do want to keep track of where you're putting your magnetic stuff, and you want to make sure that you're not magnetizing your tools. Alright, it is something that you don't really want. So you gotta think a little bit about the magnet. And they do have demagnetizers in some shops. That's kind of, you know, you can get rid of the bulk here without really kind of going into the pan and having to get it. Alright, we cleared out most of the swarp. What I really like is being able to reach down in this pit hole here where I don't really like to have the sleeves of my arms go in. And snagged a couple aluminum ones, because they were caught up in the metal ones. Alright. Alright, that's enough playing with our Wonder Wand. Alright, a little ray oil. We're going to pull this back. We're going to start setting up our boring bar and come in and do our work on the end of this. Alright, I've mic'd up the bore and I'm pretty happy with it. I've given it about 2,000 clearance now. This surface right here can be polished or buffed out a little bit. So I'm sure that I'll probably be somewhere around 3,000 or 4 thousandths over on the minor diameter of the splines. Now I want to go ahead and, because I want a visual aid out here, and I want to mark the OD or the depth of the splines itself, and I figured out that it's about 165. So I've got that set on my dial. What I'm going to do is I'm just going to put a slight bit of a machine surface out here that will represent the depth of the spline. And that should be somewhere around 2 inches 460 or so. About 5 shy. Probably the radius on here. That will be close enough anyway to go ahead and give us a visual. Yeah. Oh, well, about 8 thousandths. And it's on the shy side. So I'm going to go ahead and I'm going to take another bit in here, and I'm going to go ahead and put a nice lead angle that's going to be on the spline itself, so that it's got a good start of aligning itself as it's being installed. That'd be nice. Alright, now we're going to go ahead and we're going to pull this out and we're going to start getting it set up. Okay, this will be the side that actually slips onto the shaft on the winch, and I think we got one more cut here, and we just wanted to check and see where we're at on our dimension here. Looks pretty wet outside, huh? Okay, and we're at 2 inches 422. So we just got we got about 10 more to take out of here. Alright, we got this board out to slip onto the winch side. We've got this space and we put a good chamfer here and here. Now we're going to go ahead and we're going to turn this around and open up the bore for the spline. Alright, besides having a lot of nice inserted tools, one of the nicest things to always have on hand is a nice big boring bar. And this one here I made up quite a while ago when I first got this lathe, and I have 1/2 inch broached hole here in the end, and sometimes I'm actually using a 1/2 inch tool, and sometimes I'll use something a little bit smaller, and you can always angle it in or whatever, but you're locking it down. You're locking it from the top side down. Now I'm going to use this bar because I want a good stout bar. I'm going to even shorten this up just a little bit, and I'm going to grab a grooving tool that's going to come in and give us a nice radius so that I can plunge in and give myself a relief, because when that tool bit comes in and plunges on each one of these splines on this end here, it needs a place to relieve itself at the end of the stroke. And by setting up a groove inside with a nice radius in the bottom, I'll be able to create that escape for the tool bit at the end. So the chip will break off and it'll start its return trip, and then before it goes to the next trip there, we'll give it its feed, and so on until we get to the depth or the finished stroke on all of our splines. Alright, so I'm going to hunt up a tool bit to put in here. Right, I have a carbide braze tool bit. This is an Armstrong AL8 here that has been modified and really cut back on this side over here. This is probably pretty natural edge over here, and then that was a radius right there. It looks like probably 3/16 radius or so. It's about, or maybe 5/32 radius. That's about 5/16 on the width there. Now we're going to use this to plunge in here. Now I have my boing bar set, and I'm going to work on the back side because I like to set my zero when I touch, and then I know how far I'm cranking in. So I'm going to be working the depth of the groove more than the diameter of the inside of the groove there. And get this tight. And I went over the other side before I went and sharpened this just to get this depth here so that I'm choked in as tight as I can. And I angled the bar down a little bit so that I get the top of the tool bit closer to split line and have a better approach to the cutting edge itself. Alright, now I'm just going to come in here and I'm going to crank in to where I touch, and I'm setting 0 there, so I'll be able to go from there as 0. Now I'm to the back side of where our spline is 2 1/4, and that's where I want the space to end up being, is actually taking that 1/4 inch out down in there. So I'm going to touch there and set my dial here on the carriage. Alright, now we can go in 2 1/4 inches, and actually I'm going to go like I'm going to go 2 1/4 to start here, and I'm going to plunge in from that point there, and we will probably be rocking it back and forth slightly. We're going to go in, we're going to touch off, we're going to go to the depth there. Now the depth of our spline we said was 165, and we're probably going to make the depth of this groove at least 1875. And that'll pretty well make the transition between the 2 7/16 rough bore, straight bore on the other side, and the spline OD on this side here. Alright, now we don't need any feed, so I'm going to take that out, and we'll go ahead and we'll run it about that speed right there. And I'm going to go ahead and see if I can get some kind of oil down in there. Okay, we'll be touching in 5, 4, 3, 2, 1, and we want to get it in the right direction. Okay, touching in 5, 3, 2, 0. Sounds a lot better. You can tell when you're going the wrong way there. Just making sure everything's kind of tight here. We are getting a little bit of chatter, so that means I can probably bump it back and forth a little bit. I'm going to set my dial for 0 position here so that I can bump it back and forth a little bit. It's coming into 50. So I'm just going 20 back and forth. There's 50. Now we'll go back to the 0 center. Come in here. 75. There's 80. Alright, I'm going to go forward. 80. Go backwards. 80. We're able to at least sneak it without having a vibration problem here. Okay, back to 0. 125. Go forward 20,000. 125. Backwards 20,000. 25. This groove is relief. It's not anything special except for to be there so that we'll have clearance on the chip on the stroke of our cutter. Okay, back to 0. There's 150. We'll go ahead and call that it, even though I didn't have the chatter. 150. 150. Back to center. 1875. Just 3/16 of an inch. Same thing. And finally, okay. There we go. Alright. Now we're going to bring it out. We're going to take a look inside and see what we got. Okay, that gives us just a little bit less than 2, which is good. And you can see just a little lip. You can see it in there, a little lip on the other side. So we're going to go in a little bit and then come back out to clean off that lip there. Hopefully just trim it off a little bit. Okay, we're going to try 50 thousandths there. It actually feels like that could break almost. Oh yeah, there it is. You don't really want to pull that with your fingers though. Let's see if we can pull it with a scribe here. There we go. Alright. I really think that's clearance is pretty good in there. We'll double check our figures and we'll probably pull that off, turn it around, go in with some spring calipers and double check and make sure. Alright, we pulled this out and you can see down in there that's the bottom side of that. Actually, probably can't see it because that knob's in the way there. Alright, so what we're doing is we're just verifying that we're out far enough that we're going to be larger than the male spline or the OD of the spline. So I'm putting this down into that groove and moving it around like you would be feeling an inside micrometer. And you can hold one side stationary and the other side is just giving you a good feel that you're just barely touching. You squeeze it together and you bring it out and you let it go. And then this will give you the diameter in there, and you give it the same feel on the anvil as you did down there in the hole, and we're 2 inches 5/10. So we are We're over the diameter of 2 inches 465 by about 50 thousandths, 25 per side, which is adequate clearance for the broach to go down and relieve itself, because this board here would be interfering with the major diameter of the splines by the time it got down to there. And of course we have the mark here. Alright, now we're going to go ahead and we're going to start cleaning up our K&T, and we're going to be getting the jumping jack and our dividing head set up so that we can start broaching the spline in this hub.